characteristics of data, some things that you need to know. So some key terms. So we have what's called the center and we have what's called the spread. The center is measured by what? What do you think? What?
Median.
The median, because the median's the middle, right?
Mm-hmm.
So center, middle, median all go together. Does that make sense, guys?
Yeah.
So the center is the median. So whenever they talk about the center, it's the median set of your data. The spread is measured by,
Range.
kind of, it's measured by the quartiles. So you guys remember the first quartile and the third quartile? Okay, those numbers that you are telling me show the spread of how spread apart your data is to one another. So here's some things that we can do when making some conclusions about data. So when you're looking at something and they're asking you to describe the data, there are so many different ways that you can describe it. You can describe it based off the mean, okay, meaning the average of those two numbers. You can describe it based on the range. How far spread apart are those numbers? The quartiles, how spread apart are your first quartile and your third quartile, that inner quartile range. The median, what's the center of the data? The center, the spread, the inner quartile range, and any of like the number of pieces of data. Is there 30 pieces of data, 40 pieces of data, 20? How much data is in the thing that we're talking about? So those are just different ways that you guys can describe data. So here's what we're going to do. In this first example, we are going to describe the data shown in the plot by using as many terms above as possible. So we've got all these terms up here, and I want to use these terms to describe this data that I have right here where we talk about the ages of children in the after-school program. So I have three people that are 6 years old after school. 4 people are 7 years old after school. 5 people are 8 years old after school. 4 are 9-year-olds, 2 are 10-year-olds, and 1 11-year-old. Does that make sense, everyone? Okay, so I want to go through and figure out a bunch of different ways that I can describe this data. There's no one right way. There are a bunch. So I want you to talk to the person sitting next to you and don't write, just talk about what ways you can describe data using the terms listed up above. Go. Okay. Someone tell me something you and your partner said. Some way you can describe the data. Emery. Sorry, say that a little louder. What? The center of the data is 8 years. Excellent. Let's write that down. So the center, and then in parentheses, guys, I'm going to put median. Because center and median are kind of the exact same thing. The center median is 8 years. That is correct. What else? What else could we say? Eva.
The range is 4.
The range. Okay, it's not 4.
No.
What's the largest number?
8. Oh.
The dots are not the numbers. What's the largest number we have?
The range is 5.
The range is 5 because the largest student we have is, or largest student, the oldest student we have is 11 and the youngest student we have is 6, so it's 11 minus 6, which is, so the range is 5 years. Does that make sense, guys?
Mm-hmm.
Okay, there's 2 pieces of data. What else could we say? Jace? The first quartile is 7 years. Okay. It is. So quartile 1 is 7 years. Sam?
The number of pieces of data is 1930.
Perfect. There are 19 total students in the data set. Excellent.
The third quartile is 9 years.
Quartile 3 is 9 years. What else? If we found quartile 3 and quartile 1, what else can we find? Eliza?
The inner quartile is
Which is?
2.
Perfect. So the inner quartile range is 2 years. Okay, I want everyone to grab out their calculators for me because I'm sure this is one thing that none of you actually did. What else could we find?
The mean.
I want everyone to find the mean for me, please. If you already found it, that's awesome. If you didn't, find it for me, please. Okay, who wants to tell me what they got? The mean is what, Joe?
3.2.
Nope, too small.
31.1.
No, too big. Cooper? 8.1. So I would have accepted 8.1 or 8.05. I would have accepted as well. So remind me, guys, how do we do this one to find the mean? What do we have to do? Avery?
You have to add up like 6 3 times.
Good. So when I do this problem, guys, if you didn't get this right, make sure you redo it and check your math. It's 6 plus 6 plus 6. Then it's, how many times do we add the 7?
4.
So 1, 2, 3, 4. How many times do we add the 8? 1, 2, 3, 4, 5. How many times do we add the 9? 1, 2, 3, 4. How many times do we add the 10? And the 11? Or, you do it the way that I prefer, which there's 3 6s, that's what? 18. 4 7s. 5 8s. 3 or 4 9s. 20 and 11. I don't care how you do it as long as you make sure you add properly, okay, guys? Questions? All right, last piece of data, which we haven't discussed yet, which I want to make sure you do. Okay, there's something that we call either the data is skewed to the left, meaning most of the data is on the right, or it is skewed, it's skewed right, or it is symmetrical, meaning based on where the data is located. Okay. So for this one, would you tell me that most of the data is to the left or most of the data is to the right? So if most of the data is to the left, that means my data is skewed to the right. I know that's weird. Okay? So when I look at this, it's the opposite. So my data my data okay, let's just rephrase this because I'm going to show you something else that'll make more sense. Is most your data younger or older?
Younger.
So you would just tell me data is mostly younger. So being able to just say where a majority of your data is located. Questions on that, you guys? Okay, let's go to a blank sheet of paper in the back. Okay, so there's something that's called shape, meaning what's the shape of the data that you are given. So shape is what it looks like. It describes the distribution of numbers. Okay, so this is kind of what I was talking about. We're going to draw 3 different shapes, and we're going to draw them in histograms. It would work with line plots as well, okay? So we're going to draw 1, 2, and 3. Sorry. Okay. Then we're going to draw this. This doesn't have to be perfect, okay? So draw that one. Draw this one. And then draw this one. Okay, are we ready? So we can all tell that these 3 graphs are different, right guys? Okay. So we can either have it where it's called it's skewed to the left, it's skewed right, or it is a symmetrical graph. So skewed right, skewed left, or symmetric. Out of the 3, which one do you think would you consider symmetric?
The middle.
The middle, right guys? Why?
Because it's same on both sides.
It's same on both sides, so let's write this down. So this middle one is what we call symmetric. A symmetric graph means the left side of the graph mirrors the right side. So the right side and the left side mirror each other. If you see that, your graph is symmetric. Okay, so this is where it gets a little weird. When we look at these 2 graphs, you can easily tell that one of them's going up and one of them's going down, right guys? So the way that this works is when you look at it, it's kind of like, looks like that, right? Mm-hmm. Or it looks like that, correct? Mm-hmm. Where the line that I just drew dips, this is what we call the tail of the data, or in this case, the tail of the data. The tail is what tells you if it's skewed left or skewed right. So the side that the tail is on tells you it's to the right or to the left. So the tail is on what side? The right side or the left side?
The left.
So because the tail is on the left, that means that this data point is skewed left. And that means this data point is skewed what? Right, because the tail is on the right side. Okay, so let's write that down. So the tail extends to the left. That's why it is skewed left. Or on the other side, the tail extends right. So it is skewed right. So wherever that tail is at, that's what signifies it's right or left. Which means that on the left, where's most of the data, you guys?
Right.
On the right. And when it's skewed right, where's most of the data?
On the left.
So it's the opposite of where the majority of your data is located. So let's write that down as well. So most data is on the right. Most data is on the left. I know that's kind of weird. Okay, I'm going to give you guys a list of numbers. Are we ready? Okay, so here's my list of numbers. 4, 3, 1, 2, 4, 3, 2, 1, 0, 2, 0, 1, 1, 2, 2, 3, 5, 2, 1, 2, 3, 1, 1. Hopefully you got all those written down. I want you and your partner to draw me a line plot with those numbers. So if you all remember how to draw a line plot, because it will be on your test on Friday. So give me a line plot with your partner. Go. Should look like mine. Are we good? Okay, now that you have graphed it, now I want you to whisper to your partner, do you think it is skewed left, symmetric, or skewed to the right? Just whisper it to your partner. Go. All right, guys. What did you tell me? Left, symmetric, or right?
Right. Right.
Right. So everyone write down skewed right. Yes, ma'am.
For the ones, isn't there 7?
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yeah. Questions? Is that making sense, guys? I know that's weird, but just kind of has to be memorized. Okay, so I'm going to give you guys the rest of class to work on your homework. So what I need you to do is please take out worksheet number 13.
I'm getting on my notes. I'm keeping my notes.
Yeah.
This. So what you guys need to do, okay, is they give you this table that shows the number of apps 40 teenagers have downloaded to either phone or a tablet. So you need to take this data and you need to display it in a histogram. You are going to need to make your frequency table off to the side. So you are doing this page right here just like you did your histogram. So if you need to review how to do histograms, look in your notes on how to do histograms. Draw me a frequency table, give me the histogram. Is that understood? Then you are going to take that same set of numbers and you are going to find the 5 points for a box and whisker plot. You're going to find the IQR and you are going to draw the box and whisker plot. Is that understood? Then down below, it says to explain the differences and the similarities between the two data displays. Be sure to use any keywords to describe what each data display tells you. The more you guys can tell me in terms of what is similar and what is different, the better off you will be in terms of this concept. Is that understood? Mm-hmm. Questions at all? All right, use your time wisely.